Hi there. Let's talk about trapezoids. This is a trapezoid. Have you seen one of those before? It looks like a funny little shape, and it's got even a funnier name. But these are important shapes. In fact, if you've ever driven over a bridge and really hoped that it's held in there and like didn't fall and crash and all that stuff, then you were really relying on this shape, okay? In engineering and construction and all those wonderful things where you want things to be sturdy, triangles, trapezoids are probably your best friend, all right? We don't need to get too much into that. What our goal here is how do we find the area inside of one of these? Now, let's talk about the trapezoid as a shape, just for a minute. What does it look like? Well, it kind of looks like a triangle with its top cut off, right? Do you think that could help us find area? Well, maybe not so much, because for a triangle, to find the area of a triangle, you really need to know how tall it is, right? And we can't see that here because it's been cut. But the interesting thing is, and I mentioned this in the last lesson, is this right here is actually a part of a parallelogram, just like a triangle was. Let me show you what I mean. This has, first of all, let's talk about what this is, or what the pieces are, and then we'll make it into a parallelogram and you'll see what I mean. This one has two bases, okay? Just like a parallelogram does. And if you remember from a parallelogram, there were two interesting things about its bases. First of all, they were parallel, okay? If you could extend the two lines on a parallelogram, they would never touch. That's actually true of a trapezoid as well. These two, top and bottom, are parallel lines. They never touch. But it's a little bit different with this guy, okay? Because with a parallelogram, also the two leaning sides were parallel and they'll never touch. But with a trapezoid, notice they're not parallel anymore. In fact, if I kept drawing these two lines, they would meet, right? So we have two parallel lines here. That's important, okay? And the other thing about a parallelogram, its parallel lines, is that they were the same length. That's not happening here, right? This one is definitely longer than this one. So this is gonna be, I'm not gonna be able to use the actual parallelogram formula for this, and I'm not gonna be able to just cut it in half. But watch this. If I made a copy of this, which I just happen to have right here, if I make a copy of this, an exact copy, and I flip it upside down and line up these two sides, can you see what's happening? I actually have a parallelogram now. Cool. So this is actually half of a parallelogram, all right? That's cool. So how can I use the parallelogram formula to figure that out? Well, here's the trick, because you're not always gonna have a nice equal sides here and here. So we're gonna label this, okay? This whole thing is the base of a parallelogram. I'm gonna label this top one, the shorter one, base 1. So I'm gonna put B for base 1 in the subscript right underneath it. And this one down here I'm gonna call base 2. Okay? Because I have two different bases. They're different lengths. Now if I look at this one, it's upside down. So where's base 2 on this one? Well, it's on the top now, right? This length and this length are the same. That means base 1 is also here, since this trapezoid is upside down. That's important, because if I wanted to find the area of this parallelogram, I would have to add those two together. I would have to add this length plus this length to find out this total length if I wanted to find the area of this parallelogram. So I'm gonna write that down. That just means I'm gonna add this to this. And later, when we're dealing with just trapezoids, we're gonna add that to that, because those are both the same thing, right? Now what else? Well, in order to find the area of a parallelogram, the other thing I need to know is what's the height, right? So this base times height gives me the area of a parallelogram. That means I'm going to have to do the addition first. So I'm going to put it in parentheses so order of operations doesn't get confusing. And then I'm going to multiply that whole thing by the height. Okay? So far I have add the two bases together and multiply by the height. And what does this give me? It gives me the area of the whole parallelogram. But I don't want the area of the whole parallelogram. I want the area of it. Right? So how do I divide, or how do I cut something in half in mathematics? I take all the work I did and divide it by 2. Right? Will that work for me? Let's find out. I'm going to get rid of this, and I'm going to get rid of this. And I'm actually going to give this trapezoid some measurements so that we can try using this. Okay? So let's say that base 1, the top base, has a measurement of 3 centimeters. This one down here has a measurement of 5 centimeters. And it happens to be, let me go ahead and draw on my little cutout here, 4 centimeters tall. That should be all I need to find out what the area of this is. Okay, so let's go look at our formula over here and let's figure this out. I have base 1 plus base 2. Base 1 plus base 2 in parentheses. That's what's happening there, right? And then I'm going to multiply this by the height. So this says 4 times the sum, 3 plus 5. So far, so good? And once I find that, I'm going to divide by 2. Because if I didn't divide by 2, what would I have? If I didn't divide by 2, I would have the area of both of those. I would have the area of a parallelogram. But if I just want the area of a trapezoid, I need to cut it in half. So let's see what happens. Inside the parentheses right here is 3 plus 5. Okay? So I'm going to rewrite all this and change this right here. 3 plus 5 is 8. Still need to multiply by 4 and divide by 2. 4 times 8 equals 32 divided by 2. And 32 divided by 2 gives me 16 centimeters. And again, this is area, so we're trying to find out how many little square centimeters fit in here. And it turns out there would be 16 square centimeters in that trapezoid. What's the area of the parallelogram? Well, it's twice that, 32. Okay? Not too difficult, right? Side note, real quick. We know this is base 1, this is base 2. Do you know what to call these? I think it's funny. These are actually called legs. And each leg could have the same measurement. It doesn't have to. You'll bump into trapezoids that have 2 legs that are different lengths. And that's something that you'll worry about a little bit later on. But for now, these don't really factor into area. What you need to know is the height and the length of the 2 bases so that you can use this. Okay? Sound good? Underneath this is a link to some practice of both triangles and trapezoids. So give it your best shot. I'm not going to have an exercise review video after those, but there is an answer key. So just practice using this formula. If you turn out, if you work it out and you don't get the right answer that the answer key says, try it one more time and make sure that your process is happening by the order of operations. I think that seems to be the most common mistake. All right. Next up, we're going to spend a little bit more time finding area or finding missing lengths using the area, kind of like we did with the parallelograms. So I'll see you in the next lesson. Have fun.